Humanity is increasingly considering contingency plans for the future, whether it involves data preservation, resource management, or long-term survival strategies. When it comes to the future of our species, the stakes involve the preservation of civilization, biodiversity, and accumulated knowledge. There is a growing scientific consensus that Earth itself may eventually become uninhabitable due to natural or anthropogenic factors. The planet contains the sum of human history, culture, and biological diversity. If Earth is compromised, there is currently no technological means to restore it. Therefore, the focus extends beyond individual survival to the preservation of terrestrial life and its legacy. Earth is a unique planet in the observable universe, supporting a complex biosphere and diverse ecosystems. It is the only known location where life exists. However, despite its resilience, Earth is subject to both gradual and catastrophic changes. Over geological timescales, Earth has experienced significant transformations: continental drift, climate fluctuations, and mass extinctions. For the first time, humanity possesses the capability to anticipate and potentially mitigate existential threats. The question arises, where will humanity relocate if Earth becomes uninhabitable, and will we be prepared for such a transition? Earth's long-term habitability is not guaranteed. Astrophysical and environmental processes indicate that, eventually, conditions may no longer support life. The search for alternative habitats is a scientific imperative. Potential threats include anthropogenic climate change, artificial intelligence risks, asteroid impacts, and the gradual increase in solar luminosity. Each decade introduces new challenges, such as rising sea levels, extreme weather events, and unforeseen technological risks. These are scientifically documented phenomena that require proactive solutions. The search for alternative habitats within the solar system is ongoing. The solar system contains several candidates, but none currently possess conditions suitable for unassisted human habitation. Mars is the most accessible planet for potential colonization. It has a thin atmosphere composed primarily of carbon dioxide and surface temperatures that average around -60 degrees Celsius. Robotic missions are currently gathering data to assess its suitability for future human missions. Titan, Saturn's largest moon, possesses stable liquid bodies on its surface, primarily composed of methane and ethane. The atmospheric pressure is higher than Earth's, but the temperature is approximately -179 degrees Celsius. Human survival would require advanced life support systems. Europa, a moon of Jupiter, is believed to have a subsurface ocean beneath an ice crust several kilometers thick. Scientific interest is high due to the potential for extraterrestrial life, but accessing the ocean would require significant technological advancements. Exoplanets such as Proxima b and Kepler 452b are located in the habitable zones of their respective stars and may possess conditions suitable for life. However, interstellar travel to these planets would require propulsion technologies and life support systems that do not currently exist. The distances involved would necessitate multi-generational missions. The timing of interstellar migration is critical. Advancements in propulsion technology could result in later missions overtaking earlier ones, making strategic planning essential for maximizing the probability of success. Delaying action increases the risk of catastrophic events, rendering Earth uninhabitable before alternative habitats are secured. The window for effective intervention is limited and requires immediate scientific and technological investment. The decision regarding when to initiate large-scale migration or off-world colonization is complex. It involves balancing current technological capabilities, risk assessments, and long-term planning for species survival. The selection of future destinations, whether Mars, Europa, or exoplanets, will depend on ongoing scientific discoveries and technological progress. The future trajectory of humanity is contingent on our ability to adapt and innovate in response to existential risks.